Welcome to Dashi's Science, where our goal is to make science simple. Please like this video and subscribe to our channel so we can produce more helpful science content. Why does chemistry happen? Why do ions form? And why do elements bond together? In this video, we're going to cover the main underlying principle as to why chemistry happens and why elements bond together. Make sure you stay until the end so you fully understand this simple yet very important principle. In order to understand why chemistry happens and why elements bond together, it is important that you remember the information we covered in our valence electrons video and our drawing Bohr models video. If you do not remember this information or need a refresher, please check out our videos on these topics. Chemistry happens and elements bond together so that our elements can become stable. Stability is the reason chemistry happens. So what is stable? Elements are stable when they have a full outer shell of valence electrons. Oftentimes, this is referred to as the octet rule, which tells us that elements want to have 8 valence electrons. The prefix oct means 8, just like an octopus has 8 arms, or legs, or tentacles, or whatever you want to call them. This is true for most of our elements except hydrogen and helium. This goes back to our definition of stability, which is a full outer shell of valence electrons. As you'll see here when we look at some examples, most of our elements have a full outer shell when they have 8. Hydrogen and helium, however, have a full outer shell when they only have 2 valence electrons in that outer shell. Elements can reach a full outer shell in 2 ways, by either transferring electrons or sharing electrons. When electrons are transferred, ions form, and we call those ionic bonds. When electrons are shared, covalent bonds are formed. We will cover the specifics of ionic and covalent bonding in a different video, but let's look at a few examples of how atoms become ions so we can better understand what it means for our elements to become stable. Our first example, we'll look at the element sodium. Sodium has 1 valence electron, and if I draw the Bohr model for sodium, you can see here that it has 1 electron in the 3rd energy level. As we said, our elements want to get to 8 electrons in that outer shell. In order to do this, sodium can either add 7 electrons to the outer shell to get to 8, or we could remove that 1 electron and get rid of the 3rd energy level and move down to the 2nd energy level, which has 8. It is a lot easier to remove 1 electron than to add 7. So when sodium becomes stable or becomes an ion, it's going to lose that 1 electron to become Na+. And as you can see in the Bohr model here, for Na+, there are 8 electrons in the last energy level or in the outer shell. And this is what it means to be stable. In our next example, we'll look at the element chlorine, where we will actually add an electron instead of remove. Chlorine has 7 valence electrons, as you can see in the Bohr model here. Again, we could either add 1 valence electron to get to 8 for chlorine and a full outer shell, or we could remove 7 on the 3rd energy level and then you have the 8 on the 2nd energy level, just like we did with sodium. It is easier to add 1 electron than to remove 7, so for chlorine to become stable, all we're going to do is add 1 electron. When we do, it becomes Cl-, the anion, and now we see here in this Bohr model, there are 8 electrons on the outermost energy level, and again, this is what we're looking for our elements to become stable. In our final example, we'll look at helium, which, as I said earlier, is going to be an exception to the octet rule in that it actually will not have 8 electrons in the outermost energy level. As we can see for the Bohr model here, helium has 2 electrons in its 1st energy level, and the 1st energy level also happens to be the outermost energy level. I know that helium only has 1 energy level because it's in the 1st period on the periodic table. Furthermore, we also know that the 1st energy level can only hold a maximum of 2 electrons. So helium here with 2 electrons already has a full outer shell because its outer shell is the 1st energy level, and the 1st energy level can only hold 2 electrons. So here, helium we see is already stable. Helium is a noble gas, and just like all of our other noble gases, their outermost energy level is already stable, and that means that our noble gases will neither gain electrons nor lose electrons to become stable because they already are stable just the way they are. Now you know that elements bond together to become more stable, and that stable is when we have a full outer shell of electrons. If you found this video helpful, please like the video and subscribe to the channel to help us be able to produce more helpful science content. If there's a specific topic you need help with, please let us know in the comments.